Hi, welcome back. So the copy on the workspace is finished. I can finally have my Cloud9 account and virtual machine on the cloud set up. So this is the starting screen, and then you can see there are like different tabs here. You have a menu here on the left that you can go through it, and then preferences. You want to change your signal there. Here, like I like to have it's a nice terminal. Of course, like every other terminal you have, it's this system is based on it's Ubuntu based, so that's what it uses as a basis for the cloud system. And then as example here, we're gonna try to run just a simple example. So we're gonna go to, for example, medical. And then I'm gonna have my account. For example, here, for example, I like to build this one. It's gonna go from scratch, so just toss this one. Okay, so this one, Jump4 is building using CMake file and CMake list, and then also, like it looks like everywhere else is coming to anyone, not just by me. And then, okay, so let's go back here. So mostly the CMake list is this file here that you can see here, is in this directory. That's mostly tell you where to look for packages, what to look for, what is needed for. That's going to be needed to compile your program. And then to compile this one, we're going to compile in a directory separate, and CMake actually doesn't let you compile it in the same directory where the code is. In this way, like your code is separated from your final thing that you run is separated from the source of the code. So whatever you touch is not going to be affecting the main source of the code. So we create a directory, and people like to create a directory called build. We're going to go to this directory, and then I'm going to type CMake. CMake is already a program that's installed. I'm going to point it to the file, to the directory where the CMake list that we needed to install is there. So this experiment is called GammaTherapy, and then it's actually we're here. So we're pointing to this directory. Just check the CMake list.txt is there, and I'm going to type enter, and here. So here everything is being compiled. No, sorry, not compiled. The compiling file is created. So we just here there is you can see there's a make file here with other file that's going to be needed for run your program. So we just type make, and here we're going to scan for dependency and compile the code on the cloud machine. And okay, I'm going to give you also a percentage there on the side of what part is going on through the compiling. When it's compiling the code, I will just to show you here, there is the menu here on the left, and mostly you can navigate here again. We are in this directory here, and here there's the build directory here that is there, where it's compiling the code. Normally in Jump4 there are two directories. The main directory has a main file here that I'll show later, but the include directory have all the header, and the source directory have all the direct code, final code inside there. Obviously this one is how this program works on itself using Jump4 libraries to run. So it's not the full code is here, but it's like what something peculiar to this GammaTherapy code is inside this directory. We'll see here it's related to 88%, so the compiling of the code is mostly finished, and we are going to be able to run our first testing on this one. So you can see here the executable GammaTherapy is finished, so we have our executable. So just look ready, you just type ls-l. As here before, executable is written with x inside. It could be in a directory, it could be an executable directory, this exe file, but you can see this GammaTherapy there. So we create this file here, and then we want to try to see a certain output, and we're going to show also how to visualize the output directly that's being created by this simulation code written in Jump4. So we need to add it on this file, so we're just gonna go here on the left here and then just I don't know, on this input file there are different input files. What I like to use this one here, so we just double click on it. This is going to visualize here in our editor, and you can see here mostly there are different things you can start here. You see mostly you can use the different physics list, and physics can be created for particular for this code to run. And I don't know, you can set up the material here, you can set the Z position of the material, and what you want to do is mostly commented out this one. Things that start with this one is going to be not written. Now we commented, take away the commenting out character, and then this one is going to write is the histogram with the name of the file of this one here. This is going to decide the particle this is going to be run. You can go through there at the time. This is the energy of the particle that go. That's 50 MeV. This is how long it's going to run. Okay, so this is a system on the cloud. It's made for just testing, so we don't want to run could be not all these events, especially for just the simple testing. And here, I'm going to save this file. Go here, you see. Control S is going to save, Control Shift S is going to save as. You can change the name of the file. We want to just save it. Like this. Now we're back. Select the terminal again. Now, just again, we're going to try look our BW in, and for the thing we modify in the file are already there. So we're just going to run our simulation with we need to run in batch mode simply because there is a visualization issue when you're running on the cloud. Most of the Jump 4 is not made to use JavaScript for visualization. But so we want to run in this one. We're going to run the simulation there. It's going to run 1,000 events with electron as a bin and an energy of 50 MeV. This is the target or the setting. This is the physics we're going to use. This, and we're just going to press enter. And this one's gonna, you can then go there and read there. So you can see it run pretty fast. You can check here is still all histogram have been saved, and we're gonna look if the file is present and clear bw and st_n is there, and that's the same base of the file as we have it here. Again was bwst, and that's the same base of the file here. The format that we save it is root file format. This is commonly used in physics for analysis, especially nuclear and particle physics. But root is a nice thing for main analysis. If you want to do done post analysis on this file, you can do it. Root is also installed in this cloud system. But just to show how to visualize this one, we're going to use something else is going to be, it's already installed on this machine. That's JavaScript root. You just click on the thing there, it's going to load something here from your cloud machine, and it's already here. So we can see here there is a more selected file for reading. The problem mostly I cannot read a file from the cloud machine, I know, from some security issues because require IPTGS protocol, the cloud machine. But what we want to do is simply just download this one, the file, and this is going to be downloaded to our file here. So we're going to open one of videos here, download, and here, there, this last file there, and we load it back on the cloud. We download it on your local machine, and then we load it back on the cloud, and now we can find and visualize it here. And here are our histogram created from this one. This must show like kind of produce here on the target. I know we can do many different things like on this, but I know we can zoom there on a small part of the project on this one, create different histogram and so on. This is mostly how you're gonna visualize your root files created by your simulation. And first but not last, something that you should already been sent when you create your account. As you probably didn't notice, you have there's been sent an email to you. That mostly you can create and choose a password for your account, and then you just mostly click on this, and we need to update your password there. Oh, no, we didn't set up the password the first part. Mostly we're gonna verify our email and then write the password. So write whatever you wanna, and again, it's a password for your thing. Keep something you can remember, but not so easy that people can just hack in your account. I'm gonna create a new password, and then okay, we change our password. So next time we're gonna log in, we can just log in on this machine, and then if we wanna use another browser to log in on this account, you can just log in within your account. So for example here, so we created this password, and then okay. Whenever you are, you can just then open your previous client machine. Just click on this, and then it's gonna be a lot faster to load on this. So just give it some moment, and it's gonna load your client machine. Everything here, everything is running, is the last place where you left it last time we were working on it. And thanks for your attention. If you have questions, just drop me an email. And I'm gonna post another video on how to run the analysis and simulation for the class.